NASA allocated $2,941,394,557 to SpaceX in 2021 to build the prototype of the lunar lander Starship. However, over the past 2 years, specific updates on the progress of this lunar lander have been scarce, despite NASA's goal to return astronauts to the moon by 2026. However, there's been a flurry of new images and updates on SpaceX's HLS Starship, with NASA revealing significant progress. In today's episode of Alpha Tech, we delve into these developments. SpaceX, alongside NASA astronauts, conducted a test for the SpaceX Elevator meant for the Artemis Moon lander. The Starship plays a vital role in NASA's program as one of the 2 commercial crew lunar landers. Despite SpaceX's demanding schedule focused on initial test launches, they are actively reassuring stakeholders about their capability to undertake more intricate missions in the future. NASA astronauts Nicole Mann and Doug Wheels-Willick played integral roles in a recent comprehensive evaluation of a scaled model elevator designed for SpaceX's Starship human landing system. This crucial system serves a dual purpose, ferrying astronauts from the Orion spacecraft in lunar orbit to the moon's surface and functioning as a habitat during their approximately 1-week stay. Furthermore, it facilitates their seamless return from the lunar surface to the Orion spacecraft, ensuring the operational success of the mission. The elevator's pivotal role involves the efficient transport of both vital equipment and crew members between the habitable segment of the Starship, located near its apex, and the lunar terrain, enabling their moonwalks and essential operations on the surface. During this meticulous test, the astronauts had an immersive experience with a prototype that closely emulated the operational design of the elevator system. This hands-on encounter not only demonstrated the functionality of the hardware, but also provided invaluable insights from a crew-centric perspective, enhancing its development trajectory. Crafted and meticulously assembled at SpaceX's state-of-the-art facility in Hawthorne, California, this mock-up elevator boasts a full-scale basket section, equipped with functional mechanical components and crew interface carefully calibrated for rigorous testing. Notably, NASA astronauts donned spacesuits replicating lunar conditions, ensuring a realistic simulation during the demonstration. As part of the evaluation for Artemis 3, the crew will utilize advanced spacesuits developed by Axiom Space, ensuring compatibility with efficacy with the elevator system. The suited crew actively engaged with and provided comprehensive feedback on various aspects of the elevator control, including gate latches, interface mechanisms for deploying entry and exit ramps, cargo space optimization, and dynamic operations while traversing along a vertical rail system. These substantial advancements not only underscores SpaceX's strategic approach and technical capabilities, but also challenge any lingering uncertainties about their ability to meet the ambitious lunar landing deadline by 2030. However, amid these triumphs, legitimate concerns persist regarding the practicality and operational intricacies associated with the towering elevator design specifically tailored for lunar missions. Furthermore, within SpaceX's Starbase facilities, there's been an expedited pace in the development of crucial components for the lunar lander. Since August of 2023, a remarkable development has unfolded: the emergence of distinctive white-nosed cones that experts believe represent mock-ups of the HLS Starship variant, earmarked for meticulous testing. What sets these apart is their inclusion of life support components, signifying swift strides in critical testing protocols and a leap forward in the developmental timeline. Simultaneously, the company is navigating a phase of transformative design modifications for this monumental lunar lander, aiming to forge an optimal and finely tuned product tailored precisely for the mission's demands. Let's delve deeper into the evolution of these design models. Firstly, there are 3 significant alterations noticeable in the rocket's configuration. The foremost change is the deployment of solar panels from bays positioned atop the rocket. During the flight, these panels expand, mimicking the deployment method typical of most spacecraft. Once landed on the moon, they seamlessly retract, aligning flush with the lander's side. The second conspicuous modification pertains to the landing legs, markedly smaller and seemingly fixed in place compared to the original design, which suggested larger, potentially retractable legs. This revised approach hints at a possible reduction in weight by negating the need for leg retraction into the body. Lastly, SpaceX has strategically relocated the thrusters, situating them in multiple pods around the lander. These elevated landing thrusters are intended to minimize surface disturbance during lunar touchdown, mitigating the risks of debris and large rocks being propelled in the immediate landing vicinity. Notably, SpaceX achieved significant milestones by triumphing in a series of pivotal Raptor engine tests, a feat heralded by NASA in September. These rigorous tests validated the engine's capability to initiate and function under extreme cold conditions encountered during extended space missions, a crucial distinction of Artemis missions compared to those in low Earth orbit. These missions entail prolonged periods of inactivity in space, subjecting the hardware to temperatures substantially lower than those encountered during shorter missions closer to Earth. These strides underscore the calculated and impeccably executed nature of SpaceX's ambitious endeavors, surpassing even the most optimistic projections. At this juncture, is there anyone casting doubts on SpaceX's readiness to achieve lunar landings before 2030? Does any skepticism persist regarding SpaceX's technical prowess and capabilities? These comprehensive advancements stand as a testament to the resounding affirmative response, dispelling any lingering uncertainties about SpaceX's capacity to fulfill these ambitious lunar missions. Some individuals, upon reviewing the renderings of the HLS Starship, may still harbor reservations or lack significant confidence in its potential accomplishments. The most notable concern for many revolves around the height of the Starship's elevator. While SpaceX's proposal for the Starship lunar lander is undoubtedly unique, it presents a considerable challenge due to its towering size and weight. The massive 50-meter stack of separate spacecraft with the crew cabin at the peak would necessitate NASA astronauts to navigate a several-story ladder when traveling to and from the lunar surface. This ladder is significantly taller than the one used in the Apollo program, which NASA already had reservations about. Navigating such a tall ladder in the cumbersome and imprecise lunar extravehicular activity spacesuit would be extremely challenging and relatively risky. This isn't really a great design for a lander, and that's because, really, Starship was never intended to be a lander. Starship is primarily an orbital vehicle, the upper stage of the whole launch stack atop a super heavy booster, and was primarily designed for that role, which is why it looks like, well, a rocket. This speaks volumes about the flexibility of Starship to the extent that it can even be adjusted to suit this specific purpose. In the national team's defense, it's safe to say that demonstrated reliability would be an absolute necessity for NASA to ever accept that solution. Of course, SpaceX could feasibly include a hand-cranked backup system and a ladder on Starship's exterior in the event of total system failure, but both backups would still pose risks similar to or greater than the national team's ladder. However, the fact that SpaceX has tested a prototype of the Starship Moon elevator makes it challenging for me to believe that the company won't ultimately produce a safe, reliable elevator by 2026 when Artemis 3 begins. Indeed, SpaceX is entirely capable of accomplishing that. Just take a comprehensive look at everything SpaceX has achieved in what is considered a relatively short period in the rocket manufacturing industry. SpaceX has produced no fewer than 30 Starship prototypes and conducted numerous wet dress rehearsals and static fires, coupled with high-altitude test flights and comprehensive orbital testing. Now, the Starship Moon elevator is just a part addition to the list of these low-cost achievements. The activities in manufacturing, testing, and repair seem to pose no challenge for SpaceX. That's why NASA made the trusted choice for the Human Landing System program, opting for the lunar variant of Starship. And perhaps even SpaceX itself may not fully realize the extent to which Starship will revolutionize activities on the lunar surface. In the years ahead, the lunar variant of Starship holds the promise of advancing NASA's objectives, building upon the milestones set forth since 1972. The HLS variant of the Starship isn't solely a boon for enhancing human exploration capabilities on the moon. It stands as a gateway to unlocking potential avenues for space industrialization. Designed specifically to transport substantial payloads affordably to the lunar surface, SpaceX's formidable mega rocket holds the capability to ferry full-scale mining and construction equipment intact. Such cargo, weighing between 40 to 60 tons on Earth, constitutes a pivotal component for establishing fundamental lunar infrastructure essential for economic development and commerce. The significance of equipment within this size range cannot be overstated. It forms the backbone for laying down the groundwork necessary to foster economic growth on the moon and cultivate its commercial potential. What's even more pivotal for lunar advancement is that the diversified Starship variants will facilitate the establishment establishment of construction facilities, accelerating the expansion of an economy on this abundantly resourced natural satellite. Even amid skepticism regarding Starship HLS's deadline adherence, NASA recently unveiled unexpectedly intricate testing moments for the critical elevator component of the Starship lunar lander. This test showcased the elevator's reliable functionality, affirming SpaceX's role in NASA's lunar lander program. While SpaceX remains transparent about its strides in Starship development at its Texas facilities, a notable contrast emerges regarding the company's approach to the Starship Moon lander. This difference in disclosure methods raises intriguing questions about the Artemis mission's potential challenges, despite the technological advancements witnessed in Starship's development. As we embark on unraveling the contrasting approaches of SpaceX in sharing its Starship advancements, let's pivot our exploration towards the uncertainties looming over the Artemis mission schedule. This examination includes delving into the specifics of a recent elevator test and an analysis of how these factors might potentially contribute to setbacks. While SpaceX openly shares its strides in Starship development from its Texas facilities, understanding their comparatively reserved stance regarding the Starship Moon lander sheds light on the complexities influencing the Artemis mission's trajectory. This specialized upper stage Starship is tailored to meet the challenges of landing on the Moon and address the requirements for sustained human habitation. A vital component of this lunar lander is its elevator, a crucial element that allows astronauts to disembark and explore the lunar surface. Given that most of the upper stage Starship is dedicated to tanks or engines, it's likely that vehicles designed for Mars missions could also employ an elevator to transport crew and cargo to the surface. Recalling back the initial glimpses of the elevator, akin to one utilized by NASA's Artemis crew for lunar descent, emerged in mid-December of 2023. These reveals included model testing conducted under standard atmospheric conditions. The initial test appeared stable, prompting NASA to progress to more intricate testing stages. This recent assessment involved evaluating the elevator's performance under simulated lunar surface conditions, showcased in a newly released video clip from NASA. The footage reveals two astronauts clad in spacesuits actively operating the equipment within a simulated lunar environment underwater at NASA's esteemed Neutral Buoyancy Laboratory, or NBL, situated near the NASA Johnson Space Center in Houston. These simulated conditions aim to mimic the challenges of maneuvering on the lunar surface. Since 1992, this site has been the training ground for hundreds of spacewalks. Designed to replicate lunar conditions, this training area mimics up to 90% of the lunar surface environment. The pool floor is adorned with simulated sand and boulders engineered to imitate the regolith astronauts will navigate on the Moon. To prepare astronauts for the sandy and steep slopes of moonwalks, panels are installed on the tank floor, creating inclines and declines. Weights and flotation devices are utilized to simulate 1/6 of Earth's gravity, mirroring the Moon's conditions and enabling spacesuited divers to train effectively in this environment. NASA is meticulously recreating the unique sunlight conditions found at the lunar South Pole. While NASA hasn't provided updates on the experiment's outcomes, this step marks significant progress for the Artemis mission and specifically the Starship HLS program. With the Starship HLS elevator being an essential aspect of NASA's astronaut training, it signals SpaceX's clear mission plans, aiming to meet deadlines and ensure safe operations for the upcoming Artemis 3 program. Despite opinions suggesting SpaceX's Starship HLS might hinder NASA's lunar program, recent experiments and previous successful tests, like the Raptor vacuum engine test, the prototype life support module at Starbase, and ongoing refinements in Starship HLS design exhibit SpaceX's consistent work ethic. Their primary focus remains on launching Starship into orbit, paving the way for robust future developments. Given SpaceX's track record for speed and innovation, it's foreseeable that the new Starship HLS will swiftly follow the first Starship's orbital achievement. Alongside the attention on testing the elevator in a simulated lunar environment, there is also another noteworthy aspect: the spacesuits worn by the two astronauts. In fact, the spacesuits that the astronauts are wearing should, in theory, be designed by Axiom, the private company tasked by NASA to design lunar spacesuits for the Artemis 3 mission. But this was not to be. This indicates that the production production and manufacture of the suits are showing signs of facing many challenges, causing delays and not being able to perform double duty with the Starship HLS elevator. If the spacesuit development process slips, then it may delay the next moon landing, even if the Space Launch System and the SpaceX Starship Human Landing System are ready. Timing that has been called aspirational. One of the challenges we know about is the ability for emergency support required by NASA. NASA has mandated that Axiom develop an advanced spacesuit capable of providing a record-breaking 60 minutes of emergency life support. Axiom is facing challenges as the government reference design from NASA doesn't meet the requirement for storing the necessary amount of oxygen. Axiom is considering redesigning portions of the suit, particularly the life support system package. This may involve shrinking the size and reorganizing components to accommodate larger oxygen tanks. Alternatively, if this proves unfeasible, Axiom is prepared to modify the existing life support system, although this would entail additional time. As Axiom grapples with potential redesigns for the suit's life support system, the next hurdle emerges in the form of critical technologies. Axiom, in its mission to meet NASA requirements, aims to mature critical technologies such as the life support system and pressure garment system. As part of January of 2023, NASA evaluated these systems at technology readiness level 4. Axiom's assessment revealed that over half of its critical technologies were below TRL 6, with the regenerable CO2 scrubber rated at TRL 3 due to deviation from the government reference design. NASA expects critical technologies to reach TRL 6 by the August 2024 Critical Design Review. However, as of May of 2023, both the life support and pressure garment systems had not significantly advanced since January of the same year. Axiom had planned to conduct a crew capability assessment for the pressure garment system before the November 2023 preliminary design review. Human testing of the life support system is scheduled for CDR in a NASA vacuum chamber facility. To mitigate supply chain risks, Axiom plans to produce some components in-house. However, NASA officials caution that using a different source may decrease TRL, requiring reassessment due to uncertainties associated with a new manufacturer. Components with design changes are also rated at a lower TRL and must be matured for use in the Artemis 3 mission. Furthermore, Axiom faces potential delays in developing and procuring components for spacesuits, risking the compression of its delivery window to NASA to less than 2 years by September of 2025. Critical components, particularly those supporting the life support system, have long lead times of 12 to 18 months for procurement, so Axiom is forced to plan to outsource certain parts, such as oxygen regulators, but it's also challenging due to the limited number of specialized suppliers. For those who have been waiting for humans to walk on the moon since the last time it happened over 50 years ago, another delay would be maddening. As Axiom navigates the possibility of delays in suit component development, the potential compression of its delivery window to NASA looms on the horizon. However, these challenges aren't exclusive to Axiom, as even NASA's HLS program grapples with significant risks concerning software and hardware integration with the Orion program. The HLS system utilizes software spread across various hardware systems, making comprehensive end-to-end software testing on flight-like hardware in mission-relevant environments challenging. Although agreements have been made between the Orion and HLS programs to share emulator and simulator hardware and software, concerns arose in July of 2023. NASA documentation reveals that the HLS development pace is not aligning with Orion program integration milestones, potentially jeopardizing the planned December of 2025 launch readiness date. The integration of software developed for diverse hardware platforms, operating systems, and heritage software poses challenges and the risk of introducing defects. HLS risk documentation underscores the need for adequate test facilities and campaigns to avoid the late discovery of critical software defects during integration and testing with flight hardware. The absence of thorough testing may lead to missed critical software defects, resulting in potential cost overruns, schedule delays, or, in the worst-case scenario, mission or crew loss. As we conclude today's exploration of the Starship HLS program and the challenges ahead, uncertainties loom over NASA's lunar mission. Can Axiom overcome spacesuit development hurdles and meet NASA's stringent timeline? The compressed delivery window poses a risk, potentially delaying the moon landing. Additionally, software and hardware integration risks with the Orion program could affect launch readiness. Will agreements between programs suffice, or might they lead to unforeseen complexities? These uncertainties cast a shadow on the Artemis mission's success, urging us to ponder the path ahead in lunar exploration. Well, that's about it for today's episode. Thank you so much for tuning in. We hope you enjoyed it and learned something new. Please remember, your feedback is very important to us and helps us make better videos for you. So go ahead and let us know what you think in the comment section down below. Otherwise, we thank you so much for watching, and we hope to see you again next time.